All right, welcome back everybody to our last session of DLS for this year. This session has a lot of fun stuff and some obscure stuff. We are going to see the fun stuff from Christoph on debuggers, and then there is something AI related. I don't know whether you heard about that before, but it's a little bit obscure. So Mark, maybe could you give us a...
Well, thank you for the introduction. So, I'm loud. I'm Mark. I'm actually very excited. I was at Microsoft Research for many years, and I'm just joining the University of Kentucky, so really cool to be moving back into academia a little bit. Today I'm going to be talking about, as has been mentioned, there's a bit of discussion about AI in the air. It's going around, some excitement. And oftentimes it's people talking about AI for domain X, like I'm using AI to write code, I'm using AI to debug code. And so I'm kind of trying to pivot this a little bit and ask, as programming language practitioners, what do we want to use programming languages for in supporting AI programming agents? So turn this around a little bit and ask what role do we play in this transformation of how software is developed? So kind of the mandatory, start off. Well, is programming languages relevant in a GPTX world, right? Is it just going to be, you're going to get another order of magnitude of model size and another order of magnitude of data, and GPT-5 will write code better than any human possible, and we'll just never have to worry about programming and programming languages again? Well, I've met some great programmers, and even the best programmers I've ever met are like, there are programming language developments that I wish would happen that would make me a better programmer that I can benefit from. So I think even in this amazing scenario where GPT just continues to achieve superhuman status, improvements in programming languages are going to help it do a better job of generating code and solving programming problems, and will also help humans. So I think we absolutely have a role to play here regardless of the developments in this space. Another thing I see come up a lot is, well, right now there's just a ton of training on something like Python. There's just so much Python in the wild, so much code generated from Python. Is there some sort of snowball effect where if you're not Python, any improvements you have are just going to be dwarfed by the fact that GPT is really good at, knows all about Python. So we're kind of going to be limited to doing research on tweaks to Python, and that's about it. And I think actually one interesting thing is these models tend to generalize very well. Like they kind of understand what a programming language should look like, and they do very well with few shot learning. You give them a couple examples and they generalize pretty well. So I think it's actually quite possible to, even if you have a very niche programming language or small thing, to bootstrap it pretty quickly so that they understand it well and can work effectively with it. So I don't think we're in some sort of like, small data, trap where we can never escape from. So that's good. So I've been pretty positive here, but I think the other question is, do we need to change how we think about programming languages, programming language design, and the research we're doing? And I think this is an emphatic yes, because I think one of the big things we're seeing is programmers and programming languages are not about me at a keyboard typing in text or AST structures to implement some algorithm. They are really becoming me about the programmer curating code that's coming from previously frameworks and libraries, and now AI agents generating a lot of code. So it's not about me expressing my thoughts abstractly, but it's about me having a conversation and understanding and organizing a lot of these pieces. And I think that changes a little bit how we think about the role of a programming language as becoming the substrate for supporting this ecosystem and these development workflows. And I think that's a bit of a mindset change. So let me distill this down into a couple of questions that I think are going to be the most relevant problems and general things that we need to be addressed over the next decade or so. The first one is, how do we design programming languages for AI programming languages? Now, are these the same design decisions as you would make for a human, right? Do they have different needs? Do they have different strengths? Do they have different weaknesses? And how do we actually have programming languages to support them, not just our human developers that we've always been thinking about? The second one that's very interesting is, and I'll talk a little bit more about this, give some examples, these language tools don't understand code in any deep sense. They're language models. They see text, they see tokens, they generate text and tokens, but they don't have an intrinsic understanding of what these tokens mean. And in a sense, they can generate hallucinations or garbage or whatever you want to call it. But the question is, how do you help them? How do you give them tools that allow them to ground the output that they've generated in some model of truth about how well it addresses the user intent, it interacts with the rest of the code, it actually accomplishes its goals, right? So how are we going to have programming languages that support this kind of grounding and a bit of sort of metacognition here? You know, related to that is, well, this changes the experience of development, right? Now, how are we going to build programming languages that support workflows where humans and AI agents are both generating code and this is being integrated into larger and larger software artifacts that still need to be understandable and vouchable and reliable, right? And kind of hinting there, these actually become not just linear flows where I'm a human and I'm writing code and I'm a human and I'm telling an AI agent to do things, but I'm actually getting feedback from some of these AI agents. Like, how do we have this dialogue and develop these systems? And not only the artifacts that result from these dialogues, but what parts of these dialogues and these experiences are important to keep as artifacts in, the source control repository, codified as part of the application, just like source code, right? So I think these are really sort of big, profound questions that shift the way we think about programming language research as these agents become more and more powerful. So let me, this is forward-looking. I'm just going off the cuff from my experiences. So let me be honest about what my experiences and biases are so that you can, kind of be aware of what I might be blind to and disagree with me strongly. So I come not from the machine learning space. My background is really sort of formal methods, SMT, abstract interpretation, programming language, compiler based. So that's kind of how I approach the world. I did some very interesting work, I thought at least, sort of this natural language to formula synthesis in Excel about a decade ago, which was a big push at Microsoft there. And then I had a fun chance to work with the Codex team, building their training data set for the initial GitHub Copilot. So I got sort of a sneak peek at this world before it happened. But my experience and maybe my bias tends towards this desire to be like, when I'm synthesizing a program, and I see LLMs as kind of code synthesizers, just like the old, semantic guided abstract syntax tree enumeration synthesizers. They're a lot more powerful, but they're doing the same thing. They're taking some approximate signal and trying to generate code that satisfies that, right? My bias there was always, how do I take this possible answer and validate that it is the correct answer? And that's my bias. But as GitHub Copilot shows, well, maybe that's not the case. Like, it just spits the code in there and asks the user, figure out if this is the right answer. And it's immensely popular, and it's transformed the way a lot of people develop code. So opinions vary. I think this view on like correctness and grounding is going to be very important going forward, but feel free to disagree strenuously if you want. So let me talk about the first thing, like an example of sort of what does this mean to have a programming language that's designed for an AI agent. Now, if we start talking about, I say AI agent, I kind of talk about large language models, GPT-3, GPT-4, and they're purely textual, right? They're trained on large strings of text. They learn to predict tokens. They have some attention mechanisms to things that are maybe most relevant in the text, but they don't have any foundational understanding of what any of this text means, right? They're just generating very likely output sequences. And now we've seen in the past that code is very regular and very natural, right? And so a very good proxy for the correct answer is one that seems like it looks very natural in context, right? So they do a very good job, right? This is a very powerful thing to be able to do. But it also means that if something is not syntactically explicit in the text that they're given when they're asked to generate new code, they have no knowledge of it, and they can only use some sort of statistical prior that they've learned by looking at large amounts of code online. So an example here is, suppose I have a method named getUser, right? Now, if I look at that, if ChatGPT looks at that, it's probably going to say, well, get usually means this is pure, right? So I will assume that this text is pure, and that if I pass an argument to it and I use it later, that's going to be the same value. But that's not always true, clearly. In fact, we did a little study related to another project, and we found about 5% of all get or fetch or lookup name methods are in fact not pure. So this is an example of, if you know, for ChatGPT, it's going to basically get 5% of all its predictions using these gets wrong, right? And if you can lift this mutability or purity information into some textually explicit form, whether it's in the language design or it's in a tool built to surface purity information, and just sort of embed that, you know, some way while ChatGPT is looking at this or in the prompt construction, that's going to get you sort of a 5% improvement in its ability to generate code in these methods, right? So yeah, I guess that's subjective. So let me give you an example of some playing around I was doing with, you know, ChatGPT and generating code. So let's say I have this basically TypeScript code here, and I'm going to put this little defer block in, and I say, okay, I'd like you to generate code that implements this method, and I've provided it some natural language input to describe my intent for what this code does. I say, find the largest pair of values from two lists, and it has this function signature, takes two lists, and returns me a pair. So if I go to, you know, Copilot or ChatGPT, and I type this in and I ask it to generate some code, it returns something that looks like this. It says zip the list together and takes the max of the first value from the list and returns that arg. So, you know, it's not wrong, it's not terrible, but I don't think picking the max of the first arg matches that. So I'd say that's the wrong answer. You know, and again, it's kind of sparse here on what it has to go from. But what's interesting is, let's say I want to make it more explicit. I want to give it multimodal inputs that describe my intent. So I can go ahead, maybe I can just type in, like, this doesn't even have to be compiled. I can put this in the comment as well, but it's really cool if it's in the programming language. I can say, here's an example of an input and an output, right? And I could also maybe put in some, you know, pre and post conditions, like X should contain the first element from the return value. Now, ChatGPT, Codex doesn't know the semantics of these at all, right? It doesn't understand what these mean, but just by putting this text there, it can pay attention to things like, oh, the output contains 2 and 5, but that doesn't quite match there, and you go, and it's actually able to do a better job, and it'll generate this as its most likely solution here. Now, this is cool. This, you know, just from the text, this would look like a believable result to me. It just took the max of the first list and the max of the second list. But you can see that it fails on that example. So just by giving it more context and this multimodal ability to express my intent, we've definitely improved its performance. Now, the question is, this goes back to what I was saying about grounding. Like, how do we give it the tools to enable it to sort of have this metacognition loop where it's not just one shot, I get some prompt, I spit out some code, and I'm done, but I spit out some code, and then I'm able to evaluate in some more meaningful way whether that's the correct answer, refine my result, and build. So, okay, there are my slides. All right, so let's go back to this example here. So here, now I can say, the first thing everybody does is say, well, you got a test there. Let me run that test. And ChatGPT actually does a pretty good job with this. If you give it something like this in the prompt where you say, oh, if you give it this input, it fails, and you got this result and you expected that, can you fix this code? It'll actually go back and generate the expected answer there, or the one that matches all of the intent inputs I gave it. So you can go further than this, though, because this just sort of checks some basic sanity, right? It's not just that I wanted to produce the answer that I gave there, but I wanted to integrate within the larger piece of software I'm building, right? And so you might want to say, well, really, I'd like to then go and run a static checker on this. Like, really, this is not a good answer if it produces the right output in this example, but on other inputs, it'll immediately segfault in the following code, right? Or something like that, right? So we want to go and maybe say, hey, can I actually run a symbolic checker and say, can you generate me any input, not just this example, but any possible input, in which case this code will throw an exception. And in this case, yeah, it's pretty easy. If you give me 2 empty lists, then, you know, maxarg doesn't have anything reasonable to do other than fail. So you can go back and say, oh, you know, ChatGPT, can you recommend some spec adjustment or some fix, right? Because I can't, change this code in a reasonable way. And so it can come back and say, oh, maybe you add a precondition here. Like, I'd like to go and check and see if any of the call sites of this proposed method are going to violate this. Or maybe I should change the return value to allow you to return sort of a failure result. So this is kind of an example now. You see, not only am I just asking the coder to generate some random code, but there's actual feedback between me and that agent, right? We're having a conversation because I'm saying, oh, I need to integrate this in a larger piece of code. It can use tools to find cases where this fails, come back with multiple proposed solutions. And so the interesting question is, how does it now start communicating these results back to me, and how do I start to understand them, right? So I thought this was a fun little example because it shows using not just the source code text, but we're using, natural language, we're using input-output examples, we're using formal specs, and all of these things are a great way to communicate into the Codex ChatGPT style model to generate code. But then also it comes back with text, examples, perhaps disambiguating examples. If it's going to generate multiple solutions from the code, say, not just dump me 2 bits of code, but produce an input and say, I have one solution that produces output X, one solution that produces output Y. Which is right, X or Y? Like, it's much easier for a human to look at a single output and say the answer is right or wrong than look at 50 lines of code and guess what is there. So there's this, I think this opens up this huge area that's kind of been neglected for how do you have a much more tactile way of interacting with data and results and manipulating code in this sort of live programming experience, right? Because this becomes really a powerful way to interact with these agents, just like we do with other devs. We go to the whiteboard and we start drawing pictures and writing test cases, little test-driven development. And then the other thing that's interesting is, even today, I talk with someone on the whiteboard. Well, that artifact is lost after we erase it, right? Our discussion is disconnected from the source code, right? There's all these issues in the GitHub tracker. Those have been integrated with the source code, but these other side conversations are not part of the programming language model. And particularly if we're talking about having these interactions, multi-round interactions with one of these agents, and we're generating lots of examples and tests and witnesses and disambiguating context, we don't want to throw those all away, because if we're going to change the code and we need to go re-implement this, we don't want to lose all that context. We want to take one more interaction to improve it. So how do we encode all of these experiences back in the programming language as a holistic artifact, not just fractured bits of context, scattered in some sort of source control repository? And so I think one really important area of research that comes out of this is data, right? Data is often seen as sort of a secondary citizen in programming language areas. And I think, it's very interesting with Jan talking about loading a CSV file. It's just a bag of strings, right? And there's so much stuff out in the world that is a bag of strings or a JSON object with, unknown values. So how do we bring data in as a object of study for programming languages, right? What is that programming language for that data format? The semantics, how it needs to be composed and built and type checked and really exposed throughout the ecosystem. So let me go to an example for this. So here's sort of state of the art for data encoding in JSON, everybody's favorite language. And so I went to the National Weather Service and I got their temp thing. And so it says low, high, 25 and 34, and it's got some other strings in there. And this is a really impoverished data language for communicating between humans, but also ChatGPT. I mean, if it looks at that, low is 25 and high is 34. That's either a really hot day or a really cold day, depending on if you're in Europe or you're in the US, right? So there's not this contextual information, again, textually exposed. The only way I would know that is, oh, that I told you I got this from the National Weather Service. You'd probably guess that that was the US National Weather Service and probably guess that that's Fahrenheit, but there's a lot of guesses there, right? So, what is a data format that actually allows you to encode type and structure information explicitly in the data format in a way that allows you to link back and check it if you're doing like programming language type checking, if you want to load that CSV file and not have code that has a bunch of strings and other stuff, but like be able to load it and use it nicely. But also, if you look at this, even if I didn't give you any of the definitions of these types or anything other information on this, just from having the names textually explicit in there, you can make very reasonable inferences. And a system like ChatGPT is going to be able to key in on these and then operate on this system much more intelligently than if it was just, you know, strings and numbers. So as an example here, like we've got a little bit of code. This is back to this defer, find, max, pair. I make a bunch of calls here, right? And I can go and run this code. I can actually, now when it hits that defer, it's going to ask me, can you type in the correct answer? So I can just start, I can write my signature, I can start running my program without writing a line of code. I can go through, I can generate a couple of these examples for it, and it's nice because even though this is structured data, I can just type in the answers textually. I complete that, and now I can save off these examples off into that sort of example section, so it's all ready to go for ChatGPT, right? So this becomes kind of a workflow where, as an orchestrator for generating code, I can sit down, just write some skeleton structure, start interacting with it in a tactile, iterative way, build up all the context and examples needed for one of these AI agents, and to come in and then have all of this information to generate the code with tests, with information on how it's grounded, right? And when you start moving into a larger application context using something like React, which is very cool in the fact that it is sort of tactile, structured, data-driven, and now as they're adding multimodal support to these large language models, so I can take a whiteboard, sketch what UI I'd like, and have it generate the React component code. You can start imagining a scenario where there's this dark matter of IT and low code and semi-expert user programming. I can come in as an IT developer to somebody who says, I have an app I need you to write. Okay, so we sketch the landing page on the whiteboard. We can generate some React code, and I say, oh, what's the first thing that happened? They said, oh, we should go to the activity database and load all the to-dos. So we go in there, we have this sort of, okay, and I should name this. This is a paper from Onward 2012 called Progging, which introduced that notion of don't write the body of your code, run your code, and pop examples in. So we can go get this progging thing to say, suppose this was the stuff that came back from the database, right? Just type in some examples. And say, oh, by the way, now how should the UI look? Okay, we can, do the React render. There you go. And, our user says, yeah, that's great. And then you say, okay, now I want to add a new task. So we get sort of a new workflow. And so you can see I've, a couple of rounds of this, and almost within an hour out with my stakeholders, just walking through doing the requirements gathering that I would have to do anyway. I have the LLM agent in the background. They have a chance to just complete this app, put all these scenarios together, write the code to generate them. The other thing that's very interesting, and it's coming up a lot, is going even further on this, the notion of mixture of experts in these models. So I've always been talking about a model that generates code, right? But then you say, well, look, I have these workflows, so I really want an agent that generates the workflow structure in the application. Then I want other agents that are actually going to go and generate the code within it. And as we go back to this notion of grounding, since we have this nice structured setup, we have this nice structured programming language for how this works, we can go and say, by the way, run a checker and make sure that if I have any unhandled errors in this flow graph, I want you to go and flag these so that we can make sure that we handle them, and the agent can then iterate and improve on that. So I think this is an incredible way to bring programming languages to actually make these agents not just smart autocompletes, which they're great at today, but allow them to actually build rich applications, with some supervision, but in a very free-form way that really, especially with the grounding, people have confidence that it's doing the correct thing. So I don't see this as being, a threat to PL research that's really going to come in and disrupt and diminish the work we're doing. But I think it's actually an opportunity for us to expand what the view and role and importance of a programming language is in the world, right? It's not just there as sort of a substrate that the agent is going to, write in, but it's an actual tool that it's going to use and is going to make these AI agents much more powerful. You know, I talked about some old ideas, sort of live programming, tactile programming, probing, you know, static analysis. These are all things we've talked about a bunch, but this is an opportunity for us to show the value in the context of these agents, and I think we should really embrace that. You know, and the work that our community does is critical to empowering these AI agents to really fulfill their potential of being true co-pilot programmers, not just IntelliSense better. And, you know, it's in the name. They're large language models. They work on languages. We work on programming languages, right? So it's right up our alley. Okay, and I think that's was my slide set. So I'm happy to have any questions, critiques, disagreements, whatever.
So you had a few sections in there where you were having a back and forth with the AI agent and providing you know, answers. And I guess this is more of an idea than a question, but would it be possible to instead of providing just prompts, provide the AI agent's best guess as well, and then just have the programmer be responsible for corrections instead of doing the full answer work and have it even faster?
Yeah, I think you're absolutely right. Like, I think we want to move away, and, you know, like, I think today, Copilot generates a block of code. You have to look at it and say it does what I want or it doesn't, right? And I think the ability to have simpler ways to disambiguate between, you know, because in the background, that LLM generates top 5, top 10, top 20 answers. It just spits out one. That's obviously not going to work in the case where there are 2 or 3 plausible solutions, as I showed in my example. So it's when it comes up with 2 or 3 solutions, are there, like, I think you're absolutely on the right track. Are there better ways to disambiguate which one of those is the most relevant and explain to a developer what the different characteristics are so they can quickly and confidently make that decision? I think is a critical thing as you scale. You know, it's one thing to do 5 lines, it's 50, 500, it's a very different story, yeah.
Hi, it's an interesting talk, thank you. So during the demo, you are giving examples to teach, you know, what kind of code you need to the system. But in the demo, your way of teaching, I mean, showing an example was what the code was really looked like a code, right? You didn't, but according to my small experience with ChatGPT, I think it's a better way to use natural language like English to teach ChatGPT, to guide ChatGPT. So, for example, to me, when you're showing an example, instead of using, you know, brackets and curly braces and parentheses and comma, using more natural English-like sentence would be a better way. But what do you think about that?
I think we're at an interesting point where prompt engineering is quite a black magic, you know, and so I didn't touch on that, but I think that is going to be very interesting to see how that evolves, whether it continues to be a very important skill for the way to get the most out of the model, or if the actual training techniques do a better job of distilling out the fundamental interesting parts versus the strange quirks of, you know, telling it, I'm an expert programmer, you know, to get it to write better code, or, you know, how do you, those are a little funny, and I think the ML community is going to make some progress in reducing the amount of black magic that's needed for that. But I definitely agree. The issue of prompt engineering today is very important in how you phrase these things for ChatGPT.
Yeah, my guess was that because LLM was trained with a bunch of English text. That's why it's easy to understand English language rather than programming language.
Yeah.
But you're expert, so if you have any other
yeah, I think I think that's is going to be interesting as well, because my experience, or our experience has been that multimodal inputs are good, right? Saying the same thing but in a couple different ways. So yeah, I think that's something that needs to be quantified a lot more. I just, right now it's all you know, I tried this and it kind of worked. It's not the most empirical evaluation, yeah.
Thank you. Hello. Thanks very much for an interesting talk. I think what I'm taking away from your presentation is that techniques which make human programmers more effective, like test-driven development and programming by example, are also good for AI-based programming systems. So is that a valid takeaway message from your talk? And if so, right, dynamic languages make us really productive, don't they? So is AI better at generating dynamic language-based code rather than static stuff?
Well, so yes, I think that's the first part. I definitely agree with the statement that you know, if it makes it easier for humans to write correct code, it's also going to make it easier for AI agents to write correct code. I think that's a pretty good rule of thumb that I use. As far as dynamic languages versus static languages, I think this is a very open question. You know, so right now, ChatGPT is very good at writing Python, which is a very dynamic language. But like the example I gave about get being a pure method versus impure method, right? Or having types associated with various things, that gives more syntactic context for ChatGPT to queue on when it's generating code, which in theory should help it. It also gives you a way to run the type checker real quick and make sure that the output is, you know, syntactically, semantically at least sane, which improves the output by pruning after, you know, top 5 generation, and then we filter that list. Now, whether that's an inherent advantage and exactly what features make it a better or worse language for these AI agents, it's a very open question, and I think is going to take a while to sort out. But I'm really looking forward to, you know, getting some more understanding of that.
Hi, thank you. That was a really eye-opening talk. Just to follow up from the earlier point about these models being trained on natural language, I think the tokens they use are basically just characters, right? Or like streams of characters.
Yeah.
And I was wondering if there's any research done in training these models on the abstract syntax tree of like these languages to see if they actually understand these programming languages a little bit better and can generate better code.
So this is why I said I have this bias, because about, let's say, 5-6 years ago, yes, there was a lot of desire to train code completion models on trees and graphs-gated neural networks, right? Because obviously you have not just, you know, in the tree you have the scoping and all this structure, but if you look at the graph networks, you can also have data flow edges and other edges, and the model can learn you know, does not have to reinduce these just from the token stream. So it seems like if you had this additional structure, they would perform markedly better. But, you know, basically it is, don't underestimate the power of scale, right? So these models are more expensive to train. And it turns out if you just throw the entire internet at it and, you know, make it really wide, it learns everything that you had in that structure just as well and probably better than your sort of hand crafting of features, and you just lose to it. So this is why I said this is an open question. Well, maybe types don't help at all because ChatGPT is just really good, you know, and people have used ChatGPT to infer types for JavaScript, you know, so maybe it just learns that better than the programmer's type in, you know, annotations would even be, and it doesn't matter at all, and Python's great for that. In my view, I think types are nice, but, you know, maybe scale crushes me too. We'll have to see.
All right. Let's thank Mark again.